in this lecture, I'm going to continue on from the point we stopped at the face-to-face lecture. So I hope that you have read. Actually, this chapter has many protocols. It talks about network protocols in general. So please go through it. You have to know the definition of the terms and just brief knowledge about each of the protocol. What is the purpose of each protocol? Okay, so actually the purpose of the chapter, as you know, let us review what we had in the face-to-face lecture. The purpose is to know the protocols in the TCP/IP suites and other also protocol stack. We call the many protocols working together a protocol suite or stack. So we have defined what a protocol is, because you know a protocol actually is a kind of agreement between the sender and the translator. There could be a translator in between, so it's an agreement between sender and receiver on how the data will be interpreted and delivered to the other part. Actually, our main model always is the OSI model, which we use it as a reference whenever we talk about a network or about a stack. Now we will talk about the TCP/IP stack and Appletalk, which they are protocol stacks also. So whenever we talk about suite collection of protocols, we should remember the OSI model and how they relate to the OSI model. So in OSI model, generally data packets move down through the OSI model layers, and then there's some information added to these packets, which will include control information and together with the message content itself. So the process is called wrapping and unwrapping at the receiver side. Most network devices must support actually at least two protocols, the data link and the network. At the data link layer and network layer. So you see the routers, the PCs, all of these should at least implement these two layers. So we see these two layers when we are operating on any device, even router or any kind of device involved in the communication. We've also talked about the data transmission. So in the data transmission, there should be some agreement on how the data will be transmitted. So generally, there will be electricity, the medium of communication in general. So there should be some agreement between the sender and receiver on how the zeros and ones will be interpreted. So in translation of the volume of voltage level could range from minus, for example, -5 to +5. Okay, so regarding this, we defined some terminologies such as the voltage level, which will be the what range of voltage will represent 0, what range will represent 1, for example. The encoding method, which will be the signaling method that will be followed. The data rate, how fast the transmission will be, how many bits per second will be transmitted in the media. And also, we have seen the two types of signaling, unipolar and bipolar. So in the bipolar, the voltage can have plus and minus. It varies from the plus voltage to minus voltage, but in unipolar, the voltage is always either positive or negative. Okay, and we have also same type is called Manchester coding, which is unipolar, and it translates or interprets the data when there is a shift from the plus to the minus or from the minus to the plus. Okay, so this is the was the first part of this chapter, and then we have seen many protocols. They are called 0 or 2. So the 802. So 802 protocols, they are given by the IEEE institution. This is one of the standard bodies that issues standardizations in general. So there are many types of 802 protocols. For example, the number 1, 2, 3. The 3, which is the CSMACD, which is the carrier sense multiple access with collision detection, and it's our basis for Ethernet use. So Ethernet technically defines the cable, and CSMACD defines the way that the cable is accessed. This protocol requires that all devices on the network must listen to the cable before it can transmit. This feature is called that it's carrier sense. We call it carrier sense because all the devices need to listen before the transmission. Only one device on the network should transmit at a time. This is also one of the characteristics of this protocol, which is a part of the Ethernet, which we are using now. All the internet is actually based on the Ethernet. So also, as I said, when multiple devices transmit at the same time, this will cause something which we don't want. This will cause collision. So collision happens when many participants in the communication transmit in the same time, and the correction for this will be the retransmission again of the information. Okay, so make sure to recognize each of the standards in 802 and how they relate to network access requirements. And all of the 802 standards are compatible and work together through the data link layer of the OSI. Other 802 protocols exist for broadband, fiber optic, and token ring, but more commonly discussed and applied standards include the 802.11, which is used in the wireless LANs, and 802.15 or the wireless band, and also 8.216 for the wireless MAN. So what is BAN? BAN, actually, if you remember, we have defined many kinds of networks according to the size. So what is the difference between BAN and LAN? Yeah, the AN is the area network, but what is yeah, it's personal. Good. So the personal area network actually will be smaller than the LAN. Actually, here where we can have, for example, now you connect your mobile with the headset through Bluetooth, for example. So this can be considered as a band. It is personal. It's related to a certain person. Okay. So okay, now we see TCP/IP suite. So you see that there are many layers. As you can see, the Ethernet token ring frame relay, they operate on the physical data link. The Internet in general uses the Ethernet protocol. And then at the network layer, in which the communication goes on between the two layers, you have the IP protocol, the ARB for the translation between MAC address and the IP address. You have this one, which is for the reverse translation, similar to ARB but reverse. ICMP, Internet Control Message Protocol. Then at the next layer there are the TCP and UDP. They are different from each other in the reliability and connection orientation in general. And then the many applications can be developed at this layer. There are the famous ones which are used by other applications such as FTP and SMTP, NFS, Network File System. So in general, you can manually assign IP address. Now you are connected to the internet because you are online now, and you have a working connection. So you can see your IP if you go to the in the research in the search button in Windows, or run according to the type of Windows you have. You can find this program, the command control, and you can type the command config, ipconfig, which will show you the IP address you have and the other. Yeah, actually, the DNS, it's sometimes there is a DNS in which it gives the naming. In some networks, the PCs are given some name. For example, Ahmed PC, Ali PC, this way. So if there is a particular server, DNS is the domain name server. Okay, so it's a kind of service that has records about the names of the computers and the IPs of these computers. Okay, so there will be mapping between the names and the IPs. So generally it will be in the router itself, but sometimes it is located in another DNS. Okay, so DNS is used in the resolution of the name. In the internet, you have the www, for example, .seu. This is a name. Actually, this is not the address. This is a high-level representation of the address needed to be translated into IP address. Okay, so this translation between the name and the IP address is carried by the DNS. For the network layer protocol, there is the IP, which provides for network identification through addressing and connectionless delivery of packets. There is the ARB protocol, address resolution protocol, which provides the device MAC address from its IP address. And this is the reverse address resolution protocol, which provides the device IP address when the MAC address is known. Okay. There is also Internet Control Message Protocol, which is a management and a troubleshooting protocol. In the transport layer, there are only two in the TCP/IP stack. They are that TCP provide connection-oriented service in the delivery, which means error checking and sequence numbering. Okay, and the UDP, so Datagram Protocol, provides connectionless packet delivery services. It means no error checking, no sequence numbering, or guarantees on delivery. So the packets sent by UDP, it will not. It could not be delivered for any reason. It could come in no sequence, and it might arrive with errors. So now I'm talking in voice. Actually, the protocol of this conversation, which carries real-time data, it's based on UDP, really. Yeah. So that's why when I talk now, if your connection is not good or something, you might lose some of what I have said, or sometimes you feel that there is a problem with the sound, because they are based on the UDP. The streaming protocol is based on it. In the application layer protocols, we have the file transfer protocol, which is simply it's a protocol to send file. Okay, so you see some websites begin with FTP, and then you type the IP address. It means that there is an FTP application is running there. There is also another file transfer protocol, which is called Trivial File Transfer Protocol, used for file transfer over the internet using UDP, but requiring acknowledgement for each packet before the next is sent. So the difference is the acknowledgement. Acknowledgement means a message that is to be sent to acknowledge that data packet is received or not. The SMTP, which is used in the emails, in sending emails only, okay, not receiving email, in sending email. So you see this protocol is implemented in every mailing application. Now most of you might use Outlook. So Outlook implements this protocol. Any other interface for mailing, such as the Outlook, will also implement this protocol. There is the HTTP, which is the very famous one, Hypertext Transfer Protocol, which is gives always HTML files. It allows you to access these HTML files. So when you have a browser and you access the HTML file, the browser is programmed to display this HTML file so you can see it. Otherwise, if you will access this protocol, the purpose of it is to give you HTML files from the server. We have also the DNS, which is the domain name system, or the domain name service. It's actually the protocol that maps between the host name and the IP address in a process called resolution. So when you have a name such as www.seu, you want to get the IP of the server of this web server. This is actually this system is called. Actually, there are a tree of DNSs over the web. Okay, so DNSs are divided into a three hierarchical way, in which, for example, .com is given to one of the DNS. .net is given to another one. Also, we have in Saudi, for example, .com, .sa, for example. So inside .com there is .sa or according to the country, for example. So it is organized in this way, in a tree-like, so to be acting as a distributed system actually, and to be efficient. Okay, there is also the Telnet, which is a protocol application that provide remote terminal emulation services in clear text. Telnet is available in Windows or other operating system. You can access it, and it will be an application that provides some kind of messaging between two computers, and also some control, remote control. There is also the DHCP. The DHCP protocol, it assigns automatically your IP. So it is in IP, TCP IP, there is no automatic assignment of numbers, not like the Appletalk, as we will see. The Appletalk actually the protocol by Apple Macintosh. It's similar to TCP IP, but you know what differs in the protocol models in general, only the organization of the tasks. But all of them should have a physical layer and network layer, and after that application layer. So the DHCP assigns automatically, if it is working, for the new hosts joining the network without configuring the IP manually. There is also a simple network management protocol that enables remote configuration, monitoring and management of network devices, services and resources. So this protocol will allow the remote management of network devices. We move to Appletalk. Appletalk actually is the protocol was defined and implemented actually by Apple Macintosh. Actually this protocol was implemented according to the OSI, not like the TCP/IP. TCP/IP, they ignored the OSI actually, and it was made without giving reference to it. But Appletalk was made with reference to the OSI. It has features and benefits such as ease of addressing, as I mentioned is that network administrator assign network address or device numbers. They are dynamically assigned. Actually, in Appletalk, when a device gets inside the network, it is assigned a number dynamically, which is this is not available feature in TCP/IP, because in TCP/IP, if one of the nodes are not given IP address either by the DHCP or manually, then it will not be inside the network. It will be an unidentified node, and no one can communicate. Uh, uh, there is also built-in mechanism for limiting network traffic, such as in Appletalk, the regions are divided into zones. In another way, that because it depends on broadcast. Broadcast means sending one message to many recipients. Okay, so actually broadcasts are harmful in networks in general, because um, they make a mess in a way that the message would be traversing many links, and this will cause could cause collision and slow performance in the network in general. So to limit these effects, actually, Appletalk has a division of regions called zone, in which zone block broadcasts sent within network, and each zone can be connected to router, limiting traffic but enabling access to all connected zones. We will go through the Apple protocols also quickly. There is an EtherTalk link access protocol, which provide access to an Ethernet network. Actually, the purpose of this protocol is that Macintosh wanted to also to have their protocol to be integrated. For example, what happens if I have Macintosh computer running Appletalk and another computer running the TCP/IP? So this will link the two. Okay, we'll have the integration, provide integration means. There is also the address resolution protocol, the same as TCP/IP, and there is the link access protocol, LLAB. It's a combined physical and data link layer protocol supporting multi-point connectivity in a bus topology, and supports dynamic address work groups with up to 32 computers per work group. There is also the link access protocol, which is provide access to the token ring network. The middle layer protocols, they are the datagram delivery protocols, table maintenance protocol, name binding protocol, and transaction protocol. Okay. In the upper layer protocols, we have data stream protocol, session protocol, access protocol, zone information protocol, and filing protocol. So I would leave the definition for all of these protocols, that you have to know what is the purpose of each one. Okay, because our lesson for this week is only about protocols. So read the chapter and take notes on each of these protocol, and which layer it is found in general. So as a summary for this chapter, protocols are components that allow computers to communicate and can be understood through the OSI model, with each layer of the model represented by one or more protocols. The IEEE Standards Committee defined 802 standard, which include methods for various types of data communication. The TCP/IP suite was developed for the use on the internet, and the Appletalk protocol was developed for Apple Macintosh networks. Okay, so in order to read this chapter, you have to go through the 802 protocols, group them into logical way, and know each of them, the feature of each of them. Also the protocols inside the TCP protocol suite and the Apple protocol suite, which are two different types of models. Okay, so we consider now that we are about to finish. Actually, I wanted to talk about the assignments. We will have 4 assignments for this course, and I will provide you with the assignment when it is expected to be this week. Okay, so I will say again, don't solve or work on any of the assignment on the Blackboard. I will, when I post an assignment, I will post it by myself. Okay, so for the Blackboard material assignments, you can do them for the purpose of practice only, but they will not be included in the course assessment. Okay, so this is all for today. Let me just take your attendance, and I will see you again inshallah next week. Okay, thank you everyone, and goodbye.